Hey folks, in this video we are going to be introducing lenses, another important application of optics. Lenses are tools that we use all the time, and they are tools that are used to get light to form an image where we want that image to form. So we've got contact lenses and glasses on the left here, right? They are used to make sure that images are formed at the right place in the rods and cones in your eyes. Camera lenses are used to make sure that images form on the CCD chip in your camera or film if it's an older camera, making sure that that image forms at the right place to get a clear picture. Telescopes, a similar idea, make sure the light gets into your eyes so that you can see things from far away. Your eyes themselves are lenses. They are tools to focus light at a particular point. Microscopes, another important place where lenses are used. So very important. Let's talk about the physics of how they work. So lenses use refraction. Mirrors used reflection, the bouncing off of light. Lenses use refraction, the bending of light when it enters a new medium. So based on the geometry of your lens, the refraction that happens will occur in a certain way. Some reminders. Light bends toward the normal when it enters more optically dense glass, so a higher index of refraction, and light bends away from the normal when entering a less optically dense material such as air. So let's look at the lens geometry on the left. What might this geometry do to incoming parallel light rays? Well, this light ray, here's our normal, I drew that in there, and the light ray will refract toward that normal until it gets to the other boundary. And then here's our next normal, and it's now going to bend away from that normal. And overall, we end up with a light ray that leaves the lens like that. It's very much identical to the prism video we looked at earlier. The middle light ray passes straight through because it is incident normal to the surface at all points. And then the light ray down here, we've drawn in our normal line. Our light ray will refract toward that normal. We'll draw in the other normal for the second boundary, and we see that the light ray is going to refract away from that normal, and we end up overall with that light ray. You can see that all 3 points converged at that focal point right here. All right, what about this other geometry, this hourglass shape here? Well, there's the normal, that's 90 degrees to the surface, and the light is still going to bend toward the normal in the glass. And then it leaves the glass, re-enters the air, and it's going to bend away from this normal. And when it does that, it bends way up there. Center ray, the light just passes right on through. And then down here, drawing our normal, there it is. The light ray is going to bend toward that normal, drawing the other normal on the other side, and the light is going to bend away from it as it re-enters the air. So in the second lens, we have diverging of the light rays. They spread out. So this is this geometry on the left is what we call a converging lens, also called a convex lens. And on the right, we have a diverging lens or a concave lens. Same trick as with mirrors. The concave lenses cave in, and then the convex ones don't. So we're actually going to smooth out these lenses in general. And there's going to be infinitely many light rays that may pass through those lenses. And we're going to draw just a representative sample when we draw some diagrams for our rays. But in general, your convex lens, your incident parallel light rays all converge at the focal point, whereas your incoming parallel light rays for your concave lens, they all spread out. So, drawing a connection back to earlier content, spherical mirrors and lenses are using different light behaviors to achieve similar convergence and divergence of light. So spherical mirrors are used, they use reflection to converge and diverge light rays, whereas lenses use refraction, the bending of light in a new medium, to converge and diverge light rays. So that's our introduction to lenses. We're going to look at some of the specifics in future videos.